Good morning, afternoon, or evening. Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we're going to be talking about solving systems by substitution. There are three methods in total for solving systems. We have graphing, which we learned, but other than graphing, we have substitution and elimination. Today we're going to talk about the substitution method. And in the substitution method, it's very simple if you follow these three steps. Number one, choose an equation and solve for the variable of your choice. Try to choose the easiest one to solve for. In this case, when you look at these two equations, this y would be the easiest one to solve for. So let's go ahead and solve for that. I'm going to subtract 2x to both sides. So y equals negative 2x plus 10. You're done with step one. Step two, substitute the expression for the variable you just solved for in the other equation. Please do not plug it back in to the equation you just solved for. That will give you a wrong answer. So substitute the expression for the variable you just solved for in the other equation. Solve for the other variable. So since y is equal to y, I'm going to take the value of y and I'm going to plug it in to the y of the other equation, which will render me with 3x plus 4 times y, which is negative 2x plus 10, equals 12. Let's solve like I know you know how to do. 3x, please remember to distribute, minus 8x plus 40 equals 12. Combine like terms, negative 5x plus 40 equals 12. Subtract 40 to both sides. So I have negative 5x equals negative 28. Divide by negative 5. And x equals 28 fifths. I would go ahead and at this point leave it as an improper fraction, because later on we're going to have to plug this in, and if you turn it into a mixed number, whenever you multiply a value times a mixed number, you have to turn it into an improper fraction anyways, so why do double work? Is everyone with me so far? Okay, so now that we have this x value here, okay, we're going to plug it into the equation that we originally solved for, the y equals negative 2x plus 10, because we know what x is now. So y equals negative 2 times x, which is 28 fifths, plus 10. This is going to give me negative 56 fifths plus 10 over 1. Because hopefully you guys remember there's an invisible 1 being divided to any whole number. I need a common denominator, so this becomes 5, this becomes 50, and y equals negative 6 fifths. So the solution to this problem, which I will do in red, will equal the ordered pair where they intersect. It's still the same concept of graphing. It's the point of intersection. Could you imagine trying to graph this? That intersection is going to be a guess. It's going to be an estimate. That's why this is beautiful. Okay? So my solution is the x value, 28 fifths, comma, the y value, negative 6 fifths. Now, you can always check your answers. Very simply by plugging in the solution into both of the original equations. So let me show you how to do that. Let's go ahead and take this guy. Actually, let's combine it. Let's put it over here so that we know what we're doing. And okay. Let's do it, my friends. If this works, both equations will be satisfied. So let's check out the first equation. 3 times x, which is 28 fifths, plus 4 times y, which is negative 6/5. Does that equal 12? Let's see. 3 times 28 is 84/5. 4 times negative 6/5 is negative 24/5, which equals 12. 84/5 minus 24/5 is 60/5, which does equal 12. So it works for the first equation. Now we must test it for the second equation though. Okay? And it's 28/5 and negative 6/5. Okay. So we must test it for the second equation. So 2 times x, which we said was 28/5, plus y, which we said was negative 6/5, will that equal 10? Well, 2 times 28 is 56/5 minus 6/5. Does that equal 10? Well, 56/5 minus 6/5 is 50/5, which does equal 10. So it works for both equations. So my solution that I had originally, 28/5, comma, negative 6/5, works, and we're good. And that is substitution, my friend. Does that make sense, guys? Yeah. Okay, let's practice. Solve each equation by substitution. Sometimes it's going to be nice and easy. And they already tell you, for example, here in A, what y is already. So at this point, just plug it in. We have 3x plus 5 times y, which is negative 2x plus 10, equals 8. I took the y value and I plugged it into the y of the other equation. So this is 3x minus 10x plus 50 equals 8. 3x minus 10x is negative 7x plus 50 equals 8. Subtract 50 to both sides. Negative 7x equals negative 42. Divide by negative 7. X equals 6. Now, let's plug it into the other equation to solve for y in this particular case. So y equals negative 2 times x, which is 6, plus 10. Y equals negative 12 plus 10. So y equals negative 2. What is my solution? My solution equals 6, comma 2, the x and y value. Let's plug it in and see if this works. Well, if y is 2, we got 2 equals negative 12. I'm sorry, that's not negative. Oh yeah, wait. Did I do something wrong here? Y is negative 2. Pay attention, Mr. Morrow. So let me do that again. See, even I can make mistakes, brothers. Negative 2 equals negative 12 plus 10. Does that equal itself? Negative 2 equals negative 2, right? Because negative 12 plus 10 is negative 2. So that works. Let's see if it works in the second one. Does 18 minus 10 equal 8? Yes, it works. So we're good. Does that make sense, gentlemen? Okay, let's move on then. Next one. Which one do you want to solve for first, guys? The top one, right? Because this y is going to be the easiest one to solve for. So in order to solve for this y, I'm going to subtract 2x to both sides, giving me negative y equals negative 2x minus 15. Divide by a negative 1 to both sides. So y equals 2x plus 15. That's what I just solved for. Does that make sense, brothers? Yes, no, maybe, kind of, sort of? All right, awesome. Now that I know what y is, guys, I'm going to plug the value of y into the y of the other equation. So I've got 4x plus 3 times y, which is 2x plus 15, equals 5. 4x plus 6x plus 45 equals 5. Combine like terms, 4x plus 6x is 10x plus 45 equals 5. Subtract 45 to both sides. 10x equals negative 40. Divide by 10 to both sides. X equals negative 4. Now that I have my x equals negative 4, where am I going to plug that back into? Into this x here, correct? You guys with me here? So y equals 2 times x, which is negative 4, plus 15. So y equals negative 8 plus 15. So y equals 7. My solution, which I will put in green here, that's not green, that's blue, which I will put in green here, will be my x value, negative 4, comma my y value, 7. Does that make sense, my brothers? Let's see if it works. 2 times negative 4 is negative 8. Negative 8 minus 7 is negative 15. Works. 4 times negative 4 is negative 16. Negative 16 plus 3 times 7 is 21 equals 5. It works. Does that make sense, guys? Okay. Let us continue. Which is going to be the easiest equation to solve for here? The top one? I'd say the bottom. X, you just subtract 2y to both sides. So x will equal negative 2y plus 13 over 2. Do I have to solve for y always, guys? No. Whoever said yes, no, you're not listening. I said you can choose the variable you want to solve for. I want to solve for the easiest variable possible. In this case, all I had to do was subtract 2y to get what x was. Does that make sense, boys? Now I'm going to take this x value and I'm going to plug it into the x of the other equation. Does that make sense? Yeah? Okay, let me rearrange this so I can have space here. So we said that x equals negative 2y plus 13 over 2. Okay, I'm going to erase this so I can have space. So now I have 2 times x, which is negative 2y, plus 13 halves, plus 3y equals 9. Distribute. I've got negative 4y plus 13 plus 3y equals 9. Negative 4y plus 3y is negative y plus 13 equals 9. Subtract 13 to both sides. Negative y equals negative 4. Divide by negative 1. Y equals 4. Now I'm going to take that y value and plug it into the y of the x equals equation. So now I have x equals negative 2 times y, which is 4, plus 13 halves. So x will equal negative 8 plus 13 halves. The denominator goes to a 2 here. This goes to a negative 16. So x equals negative 3 halves. And my solution would be negative 3 halves, comma, 4. And if you plug it in and test it, it will work. Does that make sense, gentlemen? You promised me. You can ask questions, guys, as always. Okay? Next, which variable do you think would be easiest to solve for? For D. The top x, very good. By simply adding 3y to both sides. Very good, gentlemen. X equals 3y plus 5. Now I'm going to take this x value and plug it into that x. So I've got negative 2 times x, which is 3y plus 5, plus 6y equals 3. Distribute. Negative 6y minus 10 plus 6y equals 3. Now wait a second. Look at what happens here, my brothers. What's negative 6y plus 6y? 0. Now wait a second. Hold on. Is that a true statement? So exactly, my brothers. This would be no solution. These are going to be parallel lines, basically. When you have a false statement, it is no solution. And if you remember from yesterday, a no solution is known as, AKA, inconsistent. Whoever said that, I'm so proud of you. Inconsistent. Very, very good. Very proud of you guys. That was you, wasn't it, my brother? Great job. Great job. Does that make sense, guys? All right, let's keep going. Kicking butt and taking names. Who would you like to solve for here, my brothers? The y in the bottom. So I'm going to add 3x to both sides. So y equals 3x plus 2. I'm going to take that y value and plug it into the y of the other equation. So I've got 6x minus 2 times y, which is 3x plus 2 equals negative 4. 6x minus 6x, because remember I distribute, minus 4 equals negative 4. Uh-oh. 6x minus 6x cancels, so I'm left with a negative 4 equals a negative 4. Is that a true or false statement? That's a true statement. So when I have true statements, very good, son. It's all real solutions or infinitely many solutions, or also known as, you had said it before, it's dependent. It's consistent dependent. That means that it is the same exact line. So true statements, either all real numbers or infinitely many solutions, also known as dependent. You got to know that because we're in real math here. If it's a false statement, it's no solution, also known as inconsistent. Does that make sense? Now, let me show you how awesome this is with word problems. Okay, let's check this out. A music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials, including music books, CDs, softwares, etc., are shown in the advertisement. What is the cost of each lesson and the one-time fee for the materials? Okay. So we have two unknowns here, okay? We have the cost of the lessons and the one-time fee, correct? So whenever you have these, you have to define your variables. You can define them however you want. I'm going to choose that X is the cost per lesson. And I'm going to say that Y equals the one-time fee. The y-intercept, yes, because if you have no lessons, you still have the one-time fee, yes. But in this case, if you didn't have any lessons, you wouldn't be going to the piano store, so you wouldn't. It would be an obsolete thing. But yes, the concept is awesome. Good job, my brother. So now let's just pay attention, guys. For 6 lessons and a one-time fee, don't I pay $300? So 6 lessons, what are we calling lessons here? X plus the one-time fee of Y equals 300. My second equation is 12 lessons, which we called X, plus my one-time fee equals $480. That's the tough part here, guys. Once you get this, now it's Mickey Mouse time. But very important, you have to define the variables first. If you don't define the variables first, it's almost impossible to set up the equation. So now, let's solve it. Which y do you want to solve for? Because they're both easy. Okay, so we're going to solve for this y. So y equals negative 6x plus 300. I'm going to plug that y into this y. So I've got 12x plus y, which is negative 6x plus 300 equals 480. 12x minus 6x is 6x plus 300 equals 480. Subtract 300 to both sides. 6x equals 180 divided by 6. X equals $30 per lesson. You got to be able to describe what you're solving for. That's what X is. The cost per lesson is $30. But now I have to find the one-time fee. So plug this X into the second equation, or into this guy right here. Y equals negative 6 times 30, which is the cost per lesson, plus 300. Y equals negative 180 plus 300. Y equals $120 one-time fee. So my one-time fee, which I described as Y, equals $120. Yes. Have to label units, have to label what we're solving for. That is why this step right here is the most important step there is. Not only will it be easier for you to set up the equation that way, but you'll be able to understand your solutions that way. Now be honest. Is that difficult? Now I'll tell you what, that's a scary equation because you have two unknowns, but it's not scary for this class anymore. You had a question, my brother. You could plug it into either one. Let's say that I plugged it into this one right here. 12 times 30 is 360. Subtract 360 to both sides. 480 minus 360. Y is still 120. That's the beauty of this. Could I have called the cost per lesson Y, and could I have called the one-time fee X? Yes, it doesn't matter. As long as you define the variables, it is your choice. Now, let's give you a little bit of an easier one. It looks longer, but it's easy because I give you the equations. The participation rate in the workforce is defined by economists to be the number of individuals employed divided by the number of individuals 16 years of age or older. The participation rate for men is P equals negative 0.08T plus 243.96, comma, where T is the year. The participation rate, P, for women, we'll do it in a different color, is given by P equals 0.24T minus 415.10, where T is the year. Based on these models, when, if ever, can we expect the participation rate of women in the workforce to equal the participation rate of men? Well, in this case, my brothers, think about it. Isn't P equal to P, the participation rate? So when will the participation rate of men equal the participation rate of women? Set the two P's equal to each other. So the participation rate of men is negative 0.08 plus 243.96. When will the participation rate of men equal the participation rate of women, which is 0.24T minus 415.10? So in this case, we just substituted P for P. We set the P of the participation rate of men equal to the participation rate of women. And now we solve, but I made a mistake. This should be negative 0.08T. Sorry. Okay, so let's do it. Let's bring all the T's together to one side. So let's go 0.08T to both sides, giving me 243.96 equals 0.32t minus 415.10. Add 415.10 to both sides, which is going to give me 6, 0, carry the 1. That's 956 equals 0.32t. In this case, if we were in a test and I gave you something like this, I know you could do it by hand. I know you can. I believe in you. But real economists, real engineers, real architects, they use tools, so you would be able to use a calculator for this. And t would equal 2,000. No, it'd be 2,059.56 years. That's when they'll be even. Does that make sense, boys? Thomas? And boom, we're done. Hope you learned a lot. Have a great day, and thank you very much for everything.